Good morning, students. Exercise 7.3, problem number 3. Solve the determinant x plus a, b, c, a, x plus b, c, a, b, x plus c is equal to 0. So, in the same exercise, we have seen the problem. Using factor theorem, we have proved the result. Here, in the third problem, it is given solve this determinant is equal to 0. So, the determinant value is given, that is equal to 0. And you have to find the value of x using factor method. So, first you have to take the determinant that is named as delta, and you see that put x is equal to 0. So trial and error method, you have to give values for x. Put x is equal to 0. So you will get here a. Here also in this place it is b. Here you will have c. So you see that how it is ABC, ABC, ABC. So R1 is identical to R2, R2 is identical to R3. 3 rows are identical. 3 rows are identical means the value of the determinant is equal to 0. Okay, so when you substitute x equal to 0, the value of the determinant is 0. So therefore, which is the factor? X minus 0, the power 3 rows are identical. So 3 minus 1. So therefore, x minus 0 is x. So x squared is the factor of delta. Next, you have to substitute x is equal to minus of a plus b plus c. That is minus a minus b minus c. So, I have written as minus of a plus b plus c. So, when you substitute here in delta, here you will have minus a minus b minus c plus a. Okay. So, in this place you will have minus a minus b minus c plus b. Here you will have minus a minus b minus c plus c. Okay, so minus a and plus a getting cancelled. Here also you are having minus b plus b getting cancelled. Here you will have minus c and plus c getting cancelled. So therefore the remaining is, so the entries of the determinant is minus b minus c b c. Here you will have minus a minus c. Here you will have minus a minus b. So see now here I have written the transformation C1 implies C1 plus C2 plus C3. That means minus B minus C plus B plus C. So therefore, everything is getting cancelled. In the place of the first element of C1 is 0. In the same way, if you add all the three, it will become 0. If you add C1 plus C2 plus C3, that is equal to 0. So when you expand by C1, the value of the determinant is equal to 0. So when you substitute x is equal to minus of a plus b plus c, the value of the determinant is 0. So x plus a plus b plus c is the factor of delta. So next step, what you have to do? So factor theorem we are using. So is there any other factor is remaining? We have to check. For that you have to find the degree of the product of the main diagonal elements. What is it? X plus a, x plus b, x plus c. So when you take the product, it is x plus a into x plus b into x plus c, whose degree is 3. And we have found 3 factors. One is x squared. Another one is x plus a plus b plus c. So when you multiply, you will get the power is 3. X squared into x plus a plus b plus c. So the degree is 3. So the difference is 0. So the required factor is k. So therefore the determinant is equal to k into x squared into x plus a plus b plus c. Here we have to find the value of k. For that, here x is also unknown, so you have to give the positive value, simplest value, x is equal to 1. In the same way, a is 0, b is equal to 1, c is equal to 2. If you substitute, you will get the determinant. You see that here you will have x plus a. What is x? X is 1, a is 0, so 1 plus 0 is 1. Next one, here you will have b. So b value is 1. Okay, and the c value is 2. Next, here you will have a, that is 0. Here you will have x plus b. So x is 1 and b is 1. 1 plus 1 is 2. And the next one, here you will have c. So c is equal to 2. Next row. So that is in the place of a, you have to substitute 0. Next, here you are having b. So b is equal to 1. And c, x plus c. So x is 1 and your c is 2. So 1 plus 2 is 3. Here that is equal to k into x value is 1. 1 squared is 1. So 1 plus 0 plus 1 plus 2. So I have written this. So when you expand by c1, 1 into delete the first row and the first column. So 6 minus 2. So the remaining elements are 0 when you expand by c1. So here you will have 2 plus 3. 2 plus 1 is 3. 3 plus 1 is 4. 4 into k, that is 4k. So 6 minus 2 is 4. 4k is equal to 4, k is equal to 1. So we have found the value k as 1. So when you substitute here, so you will get this value of the determinant. We have arrived. But what is in the question? The value of the determinant, what they have given. So it is given this value of the determinant is equal to 0. You have to find the value of x. So given that determinant value is equal to 0, so this is the value. So x squared into x plus a plus b plus c is equal to 0. X squared is equal to 0 means x equal to 0 twice. X plus a plus b plus c is equal to 0 means x is equal to minus a minus b minus c. That can be written as minus of a plus b plus c. So therefore the values of x are x is equal to 0, 0, comma minus of a plus b plus c. In the same way we are moving to the problem number, next problem, that is the problem number 5. Okay, solve 4 minus x, 4 plus x, 4 plus x, 4 plus x, 4 minus x, 4 plus x, 4 plus x, 4 plus x, 4 minus x is equal to 0. The same way solve, that is the determinant value is equal to 0. You have to find the value of x. So first you take the determinant and name as delta. So in that put x is equal to 0 in it. If you substitute x as 0, you see that here you will have x. So all the x 0 means you will have 4, 4, 4. So that means the value of the determinant is 0 since the 3 rows are identical. If 3 rows are identical means, so when you substitute x equal to 0, 3 rows are identical. So the value of the determinant is 0. So x minus 0, the whole power 3 minus 1. So that's why it is x squared is the factor of delta. Next, if by trial and error method, you have to substitute x is equal to minus 12. So when you substitute x equal to minus 12, minus of minus 12 is plus 12. 4 plus 12 is 16. Here you will have 4 minus 12. 4 minus 12 is minus 8. Here also minus 8. Wherever you are having 4 plus x, you have to substitute minus 8. 4 minus x is 16. In this way, the determinant is felt. Now you see, we are using the transformation. R1 implies R1 plus R2 plus R3. So R1 you are going to write, this is your R1. You are going to add R2 and R3. So 16 minus 8 minus 8. So the answer is 0. Minus 8 plus 16 minus 8 is 0. Minus 8 plus 16, that is 0. So therefore in the R1 the first element is 0. So here you will have this. So the value of the determinant is 0. So when you substitute x is equal to minus 12, the value of the determinant is 0. So therefore x plus 12 is the factor of delta. Next you have to check, is there any other factor is remaining. For that you have to check the degree of the product of the main diagonal. So what is the diagonal element? 4 minus x into 4 minus x into 4 minus x. So it is 4 minus x the whole cube. So therefore the degree is 3. So we have found two factors. One is x squared, another one is x plus 12. When you take the product, it is x squared into x plus 12. So the degree is 3. Okay, so the difference is equal to 0. So the required factor is k. So therefore the value of the determinant is equal to k into x squared into x plus 12. Here you are having only both the sides. You are having x only. So substitute x is equal to 1. If you substitute x is equal to 1, 4 minus x will become 3 and 4 plus x will become 5. So therefore 3, 5, 5, 5, 3, 5, 5, 5, 3, that is equal to k into, what is your x? X is 1 and here 1 plus 12, that is 13. So when you expand by R1, so 3 into, delete the first row and the first column. First row and the first column. Here you will have 3 3s or 9. 9 minus 25. So when you go to the second element, you have to change the sign. So here you will have minus 5. So minus 5 into, delete the first row on the second column. So 5 3s or 15. 15 minus 25. Plus 5 into, delete the first row on the third column. So 25 minus 15, that is equal to 13k. So if you simplify, 9 minus 25 is minus 16. 15 minus 25 is minus 10. 25 minus 15 is 10. So if you calculate, here you will get 52. 52 is equal to 13k. K is equal to 4. So therefore the value of the determinant is equal to 4 into x squared into x plus 2. So what is given? So in that problem, solve the determinant value is equal to 0. So given that the value of the determinant is 0. So this is the value of the determinant. When it is equal to 0 means 4x squared is equal to 0, which implies x squared is equal to 0. So x is equal to 0 twice. The next one, x plus 12 is equal to 0. That implies x is equal to minus 12. So therefore x value is 0, 0 and minus 12. You are getting 3 values for x. So next we are moving to the next topic, area of the triangle. You see, now we are going to find the formula for area of the triangle. So area of the triangle whose vertices x1, y1, x2, y2 and x3, y3, that is equal to the absolute value of this formula. You need not remember this. This formula can be written in terms of a determinant. Okay, so this formula only we are going to use. So area of the triangle is equal to absolute value, that is the modulus of half into determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. Okay, instead of writing in sentence, here the first one is the absolute value, that is modulus of half into determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. So the area of the triangle formula is, this is the absolute value, modulus of half into determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. So next we are moving to the exercise 7.4, the first problem. Find the area of the triangle whose vertices are 0, 0, 1, 2 and 4, 3. So what is asked? Area of the triangle. So how many vertices? 3 vertices are given. So therefore you have to write the formula. The formula is modulus of half into determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. So in the place of x1, the vertices is 0. Here y1, 0. This is x1, y1. The second point is x2, y2. So it is 1, 2, 1. And the third point is x3, y3. So this is 4, 3, 1. And absolute value has to be written every step. Half, it is in the front, and you are going to expand by R1. So the first 2 entries are 0. 0 into anything 0. So I didn't write, only 0 is written. When you go to the next element, you have to change the sign. So minus 0 plus 1 into, delete the first row and the third column. So what is remaining? It is a 2 by 2 determinant. So 1 into 3 is 3. In between you have to write minus. 4 2s are 8. So what is 3 minus 8? That is minus 5. So minus 5 by 2. So it is written within the modulus. So therefore modulus, the number, if it comes as minus, you have to write as plus. So that is 5 by 2 square units. So we are moving to the problem number 2. So it is if k comma 2, 2 comma 4 and 3 comma 2 are the vertices of the triangle of area 4 square units, then determine the value of k. So here 3 vertices. So if the 3 vertices of the triangle of area 4 square units, what is given to you? So given here, area is equal to 4 square units. Okay, and you have to find the value of k. So what is 4 square units? That is area of the triangle. So area of the triangle formula is written. What is this? Absolute value of half into determinant x1 y1 1, x2 y2 1, x3 y3 1. Okay, so in this problem it is given the area of the triangle is 4. So here 4 is written is equal to absolute value of half into determinant. What is x1 y1? First vertex. So k2 1, x2 y2 1, x2 y2 is the second vertex. So 2 4 1 and x3 y3 1, the third row. So this is the third vertex, x3 y3. So 3 2 1 and 4 is equal to absolute value of half into, you are going to expand by R1. So what is the first entry in R1? It is k. So k into, delete the first row and first column. So it is deleted. So remain here 4 into 1, that is 4. Okay, minus 2 into 1, that is 2. So it is 4 minus 2. The same way, the second element, you have to change the sign. So minus 2 into, delete the first row and the second column. So what is remaining? 2, 1, 3, 1. 2 into 1, that is 2. In between you have to write minus. So 3 into 1 is 3. Okay, plus the third element, plus 1 into, delete the first row and the first column. 2 2s are 4. In between you have to write minus. So 3 4s are 12. So it is 4 is equal to modulus of half into, what is 4 minus 2? That is 2. 2k. Okay, minus 2 here. 2 minus 3 is minus 1. Minus 1 into minus 2 is plus 2. And here 4 minus 12 is minus 8. So here you will have minus 8. So half into 2k minus 6. So if you divide it by half, it is k minus 3. So the modulus of k minus 3 is equal to 4. So if you remove the modulus, k minus 3 is equal to plus or minus 4. So therefore k is equal to plus or minus 4 plus 3. So first you take plus 4. So 4 plus 3 is 7. Next you have to take minus 4. Minus 4 plus 3. Minus 4 plus 3 is minus 1. So the k having values, k is equal to 7 and k is equal to minus 1. If you substitute, the area of the triangle is equal to 4 square units. So next topic is singular and non-singular matrices. You see that when the matrix, that is a square matrix, is said to be non-singular and non-singular. A square matrix A is said to be singular if whose determinant A is equal to 0. If you want to say the matrix is singular, you have to find the value of the determinant which is equal to 0. If the determinant A is not equal to 0, the matrix is non-singular matrix. So exercise 7.4, the problem number 3, identify the singular and non-singular matrices. You see that first subdivision, A matrix is given. So if it is a singular or non-singular, you have to find the determinant value. So what you have to do? So first you have to write the entries within the vertical line. Here I didn't write, directly I am moving. So take the first entry, that is 1, into delete the first row and the first column. So here 5 into 9 is 45. In between you have to write minus 8 6 or 48. When you go to the second element, you have to change a sign. So minus 2 into, delete the first row and the second column. 4 into 9, what is that? 36, minus 6 7s or 42. Next, plus 3 into, delete the first row and the third column. 8 fours are 32. In between you have to write minus. 7 fives are 35. So it is 35. So when you simplify, see that here 45 minus 48 is minus 3. And 36 minus 42 is minus 6. 32 minus 35 is minus 3. So it is here 1 into minus 3 is minus 3. Minus 2 into minus 6 plus 12. 3 into minus 3 minus 9. So minus 9 minus 3, what it is? It is minus 12. Otherwise 12 minus 3 is plus 3. So plus 3 minus 3 is 0. So the determinant value is equal to 0. So therefore the matrix is a singular matrix. And see the second second subdivision you have to try as homework. Okay, and I'll move to the third subdivision. Okay, so in the third subdivision you see the question. A is equal to the matrix 0, A minus B, K, B minus A, 0, 5 and minus K minus 5, 0. So you have to check whether it's a singular or non-singular. So you have to find the determinant value. So I have written the entries within the vertical line. I'm going to expand by R1. So the first entry is 0. So 0 into anything, 0. So it is 0. Next, when you go to the second element, you have to change the sign. Here you are having two elements, A and minus B. So minus of A minus B. And delete the first row and second column. So what is remaining? Here you will have B minus A. So B minus A into 0. That is 0. In between you have to write minus. Okay, minus K into 5 is minus 5K. Already one minus is there, so it will become plus 5K. And you have to write the third element K. So delete the first row and the third column. So when you multiply it as minus 5 into B minus A minus, when you multiply these two, that is minus K into 0 is 0. So you will get this answer. So minus of A minus B into 0 plus 5K is 5K minus, when you multiply these three, here you will have minus 5K into B minus A. So if you apply the minus inside, this B will become positive, this A is minus. So B minus A into 5K. This is minus B minus A into 5K. Both are same terms. One is in plus, another one is in minus. So therefore the determinant value is equal to 0. So therefore A is a singular matrix. So next problem we are moving to determine the value of small a and b so that the following matrices are singular. So it is given the following matrices are singular. If it is a matrix or singular means what will come? Singular means it's whose determinant value is equal to 0. If it is non-singular, the determinant value not equal to 0. So in this problem, it is given that the value of the determinant is equal to 0 because the matrix is singular. So see the first subdivision, A matrix. Given that A is singular, so determinant A is equal to 0. So write the entries within the vertical line which is equal to 0. So how to evaluate the 2 by 2 determinant? 7 into A, 7A. In between you have to write minus. When you multiply these two, minus 6. So minus of minus 6 is plus 6. That is equal to 0. So 7A is equal to minus 6. A is equal to minus 6 by 7. And coming to the next one, that is the second subdivision. B 3 by 3 matrix is given. This matrix is a singular matrix. That means B is singular. If B is singular means whose determinant value is equal to 0. So therefore the determinant, the values, the entries of B is written within the vertical lines is equal to 0. So you have to expand by R1. So take what's the first element? The first element is B minus 1. So write it. Delete the first row and the first column. So what is remaining? 1, 2, minus 2, 4. So you have to multiply 1 into 4. Okay, 1 into 4 is written. So next in between you have to write minus 2 into 2. Where it is? Minus 2 into 2 is minus 4. So it will become plus 4. And next when you go to the next element, you have to change the sign according to the cofactor. So it will become minus 2. Okay, delete the first row and the second column. 3 into 4, that is 12. So 12 is written. In between you have to write minus. Next one, 1 into 2, that is 2. So you have to go to the third element, plus 3. Delete the first row and the third column. So you have to cross multiply. 3 into minus 2 is minus 6. In between you have to write minus. 1 into 1 is 1 is equal to 0. This is b minus 1 into 4 plus 1 is 4 plus 4 is 8. Minus 2 into 12 minus 2 is 10. Plus 3 into minus 7 is equal to 0. So it is 8b minus 8. So 8 into b is 8b. Minus 1 into 8 is minus 8. 2 into 10 is minus 20. 3 into minus 7 is minus 21 is equal to 0. So 8b is 8b. And if you add all the numbers, it is minus 49 is equal to 0. So b is equal to 49 divided by 8. So next, the fifth problem, it's important. That is a repeated problem. See that what is given, cos theta is equal to cos 2 theta is equal to 0. Determine the determinant the whole square. So we have to find the value of the determinant. Okay, so first you take the result. Cos 2 theta is equal to 0 means cos 2 theta trigonometric formula is cos square theta minus sin square theta is equal to 0. So cos square theta is equal to sin square theta. The minus sin square theta, when you take it to the next side, it is plus sin square theta. So cos theta is equal to sin theta. Cos and sin values are same when theta is equal to pi by 4, that is 45 degree. You consider the determinant whose value has to be found. Okay, so in that, in the place of theta, you have to substitute pi by 4. So here cos pi by 4, sin pi by 4. Here cos pi by 4, sin pi by 4, cos sin pi by 4, cos pi by 4 the whole square. So you know that the cos 45 degree and sin 45 degree is 1 by root 2. So next step I have written 1 by root 2. Okay, here everything is 1 by root 2 is written. So the whole square. So it is a determinant. You see the first row, what is common? 1 by root 2. In the second row also 1 by root 2. In the third row also 1 by root 2 is common. So from each row you can take 1 by root 2 out in the determinant. So that is 1 by root 2 the whole cube. Because each row, 3 rows are there. So it is 1 by root 2 into 1 by root 2 into 1 by root 2. That is I have written as 1 by root 2 the whole cube. Why it is raised to the power 2? Here the determinant value the whole square. So for this value also you have to raise to the power 2. And what is remaining? It is 0, 1, 1, 1, 1, 0, 1, 0, 1. It's not minus 1, 1, 0, 1. The whole square. Now you have to expand by R1. So first entry is 0. When you go to the second entry, you have to change the sign. That is minus 1. Delete the first row and the first column. So 1 into 1 is 1 minus 0 plus third entry 1 into. Delete the first row and the third column. Here 1 into 0 is 0 minus 1. So minus 1 into 1 is minus 1. Here also 1 into minus 1, minus 1 the whole square. Here you see that it is 1 by root 2 the whole cube to the power 2. So you can interchange this power. So this root 2 and 2 getting cancelled. So you will have 1 by 2 cube. 2 cube is 8. Here you will have minus 2 the whole square. Minus 2 into minus 2 is 4. So 4 by 8, that is equal to 1 by 2. So see the sixth problem. Find the value of the product. So the entries are in the logarithmic function. So see now, log 64 to the base 3, log 3 to the base 4, the first determinant. So determinants means, as usual, you can multiply first row, first column. So here the base is 3, here the number is 3. If they are same, you can write when you multiply log 64 to the base 2. Okay, here the base is 3, here the base is 3, here the number is, here the term is 3. So if they are same, you can write log 64 to the base 2. And you have to multiply these two. So here both the base as well as the numbers are same. So it is 1. Okay, if you cancel, it is your answer is 1. It is a logarithmic rule. Okay, and you take the first row and the second column. Here also you see 3. Here the entry is 3. So it can be written as log 64 to the base 8. First row, second column. And if you multiply these two, so the answer is 1. Okay, you see that log, here you will have 4, here you will have 4. So therefore it can be written as log 3 to the base 3. So log 3 to the base 3 is 1. So that's why log 64 to the base 8 plus 1. And take the second row and the first column. See here the base is 3, in that the number is 3. So it can be written as log 8 to the base 2. When you multiply these two, it is log 9 to the base 3. Here second row, second column. So log 8 to the base 3 into log 3 to the base 8. So therefore it is log 8 to the base 8, that is 1. And log, and see that where you have to multiply these two. So here the base is 4, here the number is 4. So it can be written as log 9 to the base 3. Okay, the 64, here you are having the base is 2. So 64 can be written as 2 power 6 plus 1. Here 64, the base is 8. So the same 64 can be written as 8 squared plus 1. Here 8, the base is 2. So the 8 can be written as 2 cube. So log 2 cube to the base 2. Here the base is 3. So the 9 can be written as 3 squared. And 1 plus log. Here also the base is 3. So the 9 can be written as 3 squared. So in logarithmic, log a power m. Log a power m to any base can be written as m log a. So therefore the 6 will come to the front, and here what you will have log 2 to the base 2. Log 2 to the base 2 is 1. So therefore 6 into 1 is 6 plus this one is written. Okay, in the same way here also log a power m. So in the m will come to the front, 2 into log 8 to the base 8. Log 8 to the base 8 is 1. So 2 into 1 is 2 plus this one. Okay, and here you will have this 3, the power 3 will come in the front. The same way log 2 to the base 2 is 1. So 3 into 1 is 3 plus here the same way this 2 will come to the front, 2 into 1, that is 2. Here you will have 1 plus. So this 2 will come to the front, that is log a power m is equal to m log a. So this is 2. What is 6 plus 1? That is 7. And 2 plus 1 is 3. And 3 plus 2 is 5. And 1 plus 2 is 3. So you have to find the value of the determinant. So if you cross multiply, 7 3s are 21 minus 15. 21 minus 15 is 6. Thank you, students.